GATE 2015 Civil Engineering Set 2 Question 41. A 6-meter high retaining wall having a smooth vertical back face retains a layered horizontal backfill. Top 3-meter thick layer of the backfill is sand having an angle of internal friction phi equals 30 degree, while the bottom layer is 3-meter thick clay with cohesion of 20 kilopascal. Assume unit weight for both sand and clay as 18 kN per meter cube. The total active earth pressure per unit length of the wall in kN per meter is. The four given options are A 150, B 216, C 156 and D 196. The relevant NPTEL reference has been listed. So if we are given a retaining wall which has a horizontal backfill, let us assume that the retaining wall has two layers, H1 and H2. So the height of the first layer is H1 and the height of the second layer is H2. Assuming first layer is sand whose cohesion will be 0 and angle of internal friction will be some value phi. The bottom layer can be assumed as clay with some cohesion value. The Ka for this will be 1 as phi will be 0 degree, and the Ka for the sand layer would be equal to 1 minus sine of phi by 1 plus sine of phi. Now we will draw the active pressure diagram for these two layers. So we had the retaining wall and the backfill is horizontal. So due to the sand layer there will be a certain active pressure. So that would increase till here. So that would be given by Ka of sand into gamma of sand into the height H1. That would be this value. But due to the clay, what happens is the active pressure is given as Ka gamma H minus 2C root Ka. This is due to the cohesive nature of clay. A negative term gets added to the equation. So this value would get reduced by minus 2C root Ka. And then depending upon the density of clay, this will increase again to a certain extent, where this would be sigma 1 if this is, so this would be sigma 1 plus the Ka of clay into the gamma of clay into the height of the clay layer. So the area of this diagram would be equal to the active pressure getting acted on the retaining wall. So in this case the retaining wall has a height of 6 meter and the top 3 meter is sand and the bottom 3 meter is clay. For the sand, the properties that are given are phi is 30 degrees. So from this the Ka would be equal to 1 minus sine of phi by 1 plus sine of phi. So that would become 1 minus 0.5 by 1 plus 0.5. That would become 1 by 3. For the clay, the values that are given are cohesion of 20 kilopascal and the phi value will be 0. This would make the Ka for the clay equal to 1. So as far as the sand is concerned, the pressure diagram would start and reach at a certain point. So that point would be equal to the Ka of sand into gamma sand into the H1 height, that is 3 meter. So the layer 1 is 3 meters and the layer 2 is 3 meters. And it is also given that the density of sand and clay are equal and are 18 kilonewtons per meter cube. So this would become 1 by 3 into 18 into 3, that would become 18 kilonewton per meter square. But due to the nature of the clay, this value will get shifted here. So that would be determined by active pressure, which is Ka into the vertical stress at the point minus 2C root Ka. Here the Ka will be taken for clay. So this would become 1 into the vertical stress, that would be 18 density into the height 3 minus 2C, where C will be 20 and Ka is 1. So this would give the value to be 14 kilonewton per meter square. So from 18 this value would go to 14 and then it will again increase depending upon the density of clay. So that would become equal to Ka of clay into gamma of clay into the height of the second layer. So that would be 1 into 18 into 3, that would be 54 kilonewton per meter square. But this 54 will be in reference to 14, so that would become 54 plus 14, that would be 68 kilonewton per meter square. Now we know all vertices of the triangle, so now we can find the area of the triangle to determine the active earth pressure on the retaining wall. So this triangle or the triangular shape can be divided into three shapes. So this is A1, this is A2 and this is A3. So we will find each of them, then add them together. So A1 would be equal to half into the base. So the base for A1 is 18 and the height would be 3. This would give the value as 27 kilonewton meter. Then we have A2 is a rectangle. So the height for A2 would be equal to 3 and the width for A2 is 14. So that would give 42 kilonewtons meter. Then we have A3, that is also a triangle. So half into the height, that is 3, and the base for that will be 54. So this would turn out to be 81 kilonewtons meter. Now adding the three values, A1 plus A2 plus A3, that would be the active earth pressure. This value would become 150 kilonewtons per meter. So the total active earth pressure per unit length of the wall is 150 kilonewton per meter, that is option A. The relevant NPTEL reference has been listed.